Guys, we're back with another transformation. So we just did translations last time. This time we're going to do reflections. Okay, and we're going to read this fancy definition and then we'll show you kind of what a reflection looks like. So it says a reflection is flipping a shape without turning it or changing the size, and it is just a flip. And you see reflections a lot in real life when you're like looking in the mirror or whatever. And we have our bear friends here because, again, we're very lonely. And it's kind of hard to show you a reflection with this bear because I don't have a mirror. So to help us, we have a second bear. All right, so if I want to show you the reflection of this bear, it's going to be that I'm creating like a mirror image. So to help me with that, I have a second bear. All right. So my top bear right here, hello. This is my pre-image. This is where she started. And then I flipped her, bam. And now we have the reflection down here. And he's upside down and he is the same size. He didn't like slide over here. He didn't do anything weird. He just flipped upside down. Okay? All right. Let's get some more explanations in here.
All right. Thank goodness for bears, because otherwise, how was I going to hold Miss Benson up like that? I mean, I just don't know. Okay, so here we go. Again, we have a pre-image and an image. Pre-image is what happens first. It's the original image, the original bear. Then we have our image, which is the image after the transformation. And that would be A prime, B prime, and C prime. So again, you have to make sure you know where your y-axis is. That's this one. And your x-axis, which is this one. And if you look at this tiny little example here, you'll see this is our y-axis. And this triangle is the pre-image. I know that because it's triangle A, B, C. But when we flip it over that line of reflection, then we have A prime, B prime, and C prime. So it's the exact same shape and size, but it flipped over this y-axis or that line of reflection. Okay? Now let's see what this looks like when we're doing a math problem. Your turn, Miss Benson.
Awesome. I don't have the bears this time, but here we go. Okay. So let's do an example. And this is actually going to be a two-part example, so I'll try not to take all day. My directions begin by saying, reflect the shape over the x-axis. And over here, I have spaces to write the coordinates of my pre-image, the shape that I'm starting with. And then I have a space to write the coordinates after I reflect it. So let's fill in this first table with the points of triangle ABC right now. So A is at +3, -2. B is at +3, -4. And C is at +2, -3. All right, there's my coordinates of my pre-image. It's the shape before I did anything. Then I'm going to reflect over the x-axis. And the best way to remember what you're doing is to highlight or trace the axis that you are reflecting over. So even if you just have a pencil, that's fine. Just trace with a pencil over that line. And then I'm going to flip this guy over that line up here. Almost imagine like I am folding this and it stamps onto this part up here. Okay? And the way that we do that is actually not so hard, as long as you can count to like 3. Okay, I'm going to count how far point A is from the x-axis. So it is 1, 2 blocks from the x-axis, and I'm going to put its reflection 2 blocks on the other side. So 1, 2, that is where A prime is going to go. And then I'm going to do the same thing with B. I'm going to count how many blocks from the x-axis. 1, 2, 3, 4. So I'm going to count 4 on the other side. 1, 2, 3, 4. And that's where B prime goes now. Let's do the same thing for C. C is 1, 2, 3 spaces from the x-axis. So I'll go 1, 2, 3 spaces from the x-axis. Okay? And you don't have to connect these points. Again, it really has to do with how neat you are and how you want your paper to look. I'm going to connect them this time just so y'all can see both ways.
That's very nicely done.
So there's my new triangle. Thank you. There's my new triangle. This is my image. And it looks kind of the same, but if you notice, B used to be on the bottom and now B prime is on the top. So it did flip. We're going to write the coordinates of that triangle. Okay, so A prime is at 3, 2. B prime is at 3, 4. And C prime is at 2, 3. Now, some of you might have noticed a pattern over here. You can ask your teacher about that if you want to know more information. Okay, because I've got something else to show you. All right. So we are actually going to do a second problem on this same page, just so we can practice everything. All right, down here at the bottom, right underneath the picture, it says, okay, now try reflecting it over the y-axis. So let's try it that way. This is my y-axis, and I'm going to reflect this guy over to here. Okay, and we're going to do it the same kind of way. I'm going to count how far each point is from the y-axis and then go that many spaces on the other side. So A is 1, 2, 3 spaces from the y-axis. So A prime will be 1, 2, 3 on the other side. A, except this time I already have an A prime, so I'm going to call it A double prime. I'm just going to give it 2 apostrophes. I'm going to do the same thing with B. It's 1, 2, 3 spaces. So my image of B will be 1, 2, 3 spaces. And then let's do C. 1, 2, go 1, 2. That's where my C is going to end up. And this time it's really easy to see that my triangle has flipped, right? Now it's pointing in a whole different direction. So let's wrap this up and get this example done by writing out some coordinates. The image of A is at -3, -2. B double prime is at -3, -4. And our new C is at -2, -3. And you might be able to find some patterns here as well, but I'll leave that for another time. And that's basically everything to know about reflections. You just gotta count.
Yay!